Good evening, everyone. Happy Independence Day. Am I audible? Please confirm. You can confirm in the chat box as well. Am I audible and clear? My voice is clear? Okay, I think it's clear. Thank you. Okay, so happy Independence Day once again to all of you. Now we'll start the session. So this is environmental chemistry course offered by IIT Roorkee, and I am the TA for this course. My name is Mansi Tripathi. As you can see here also, I am a student of IIT Madras, a PhD student, third year. So I'll be taking this course. I'll help you in solving the doubts and all. So I'll show some questions. There will be options. You can try to solve those questions. In case of any doubt, you can ask me in between. Okay, so we'll start the session. I'll share my screen now. I hope it's visible. So this is week 3 of environmental chemistry problem solving session, and these are my work. Okay, I'm a research scholar. I'm PMRF research scholar at IIT Madras. So week 3, what was there? So mostly in the first 3, or we can say 4 lectures, it was too much of maths. Okay, so no need to get scared of that. You can watch videos 2 3 times. You can note down everything in your notebook and you can go through it. It's not that difficult. If you are once you get the concept, it will be easy for you. Okay, you don't have to mug up all the equations and everything. Just try to understand the concept, and once you will start solving the questions multiple times, if you are solving questions multiple times, then all the formulas will automatically, you will be able to remember everything. Okay, just practice problems. Just try to practice as many problems as you can. In this session, I'll show 10 problems. In your assignment, there are 10 more problems, but you can find some books. I can suggest a book also. Almost the books sir has suggested in the first lecture. All those books have many problems you can solve. Okay, so we'll start with question number 1. So question number 1 is just we have to match the following components. So there was one equation, I hope you remember, which is not in steady state. A basic equation, we have to see that how the mass is accumulating, incoming flow, outgoing flow, as well as whatever the changes that are happening inside the reactor. The reactor can be of any type. It can be batch reactor, batch, PFR, and completely stirred flow tank reactor. Okay, uh, so there can be many types of reactor. So these set of equation, first, second, third, fourth, will form a basic equation, and by changing the values of the reactor reaction part, we can get to either plug flow reactor, batch reactor, or the third type of reactor. And if the condition is steady state, we can directly put dc by dt is equal to 0. We can get to another set of equation. So please try to solve this question and answer in the chat box. We'll see the answer in a while. We'll see the answer now. So the correct option is option B. So this is the explanation for that. This V dc by dt explains the accumulated mass. Why the mass is accumulating? If there is more incoming and less outgoing, obviously there will be some accumulation inside the reactor. For example, let's talk about a batch reactor. Just imagine that this part is zero. For a while, let's imagine this part is zero. Okay. If the flow is coming at 5 ml per second and the outgoing flow is 3 ml per second, so there will be some accumulation, right? Accumulation of water or whatever the pollutant we are considering which is coming. So therefore there will be some accumulation. So this terms define that how much accumulation is there, not in terms of water but in terms of pollutant. The C is there, right? So this equation you might have studied in your hydraulics also. Like when you were studying this in hydraulics, it was in terms of water, but now it is in terms of the pollutant, which like target pollutant for which we are talking about. So this is the accumulation term. This is the incoming. I represents incoming. Okay, so that it's quite easier to understand. Q naught C naught. Here O QOCU, let's call it. It represents outgoing flow, and this is the volume of reactor and rate of forward formation and rate of loss. Okay, so this is the basic mass balance equation that you should remember, and depending upon this equation only, if this is steady state, this term will become zero. If this is a batch reactor, this term will become something else. Different types of reactor, this there will be changes, and if it is plug flow reactor, this T will become theta. Okay, moving towards next question. The following data provided is relevant to the next two questions. So this is the data that please note it down. Next two questions, question number 2 and question number 3, will use this data. Okay, so if this is not visible clearly, this is an arrow, means x is converted to y, and these are the stoichiometric coefficient. The stoichiometric coefficient of x is 1 and y is 1.5. And this line is important, that assume molar mass of compound x is equal to 0.5 molar mass of compound y. Okay, means x is equal to 0.5 y, and this square bracket represents molar concentration. Okay, not activity, it's concentration. So basically we will talk about concentration now. Okay, so because we can say the sample is diluted, it means activity will be equal to concentration. So now in most of the cases we will talk about concentration only. Here inflow we are seeing means Q in. This, the volume of tank is 500 liters. The raw wastewater contain carcinogenic compound X and compound Y with the concentration of 500 milligrams per liter and 10 milligrams per liter. Okay, so the raw water contains X as well as Y. These are the concentration for the same. So rate constant is 4 per day, means what is this? K. Okay, so this is the molar compound. This I have already explained, this part. So please note down everything so that we can move forward to next slide to see the question. We'll see the question number 2. So what is the concentration? Oh, answer is already there, but I'll try to explain. First, you try to solve the question on your own, then you can see the answer. Now, for now, you can see it all right. So, what we are supposed to calculate the concentration of compound X in the effluent. Means, just say it is a it is a continuous stirred tank reactor. Okay, this is the sign of stirring. Volume of the reactor is 500 liters. How much inflow was there? 2 meter cube per day. And what was the outflow? Uh, okay, then how much X was coming? 500 milligrams per liter. How much Y was there? 10 milligrams per liter. So, first of all, we need to calculate the amount of X. First question is X, next question is Y. So, we know the volume. Everything is in meter cube, so that's why we converted volume from liters to meter cube. Theta is equal to 0.5 by 2. Okay, 0.25. So this is all we have seen in the equations. Okay, sir has explained. If in case of any doubt that how we are getting to these equations, please refer to the lectures. I think week 3, lecture 2 or 3. Please refer to the lectures, go through it very properly again, then you can get all these equations. If this equation is for CSTR, then for plug flow reactor also we had this kind of equation, C naught e raised to power minus kT. This is for PFR. So you don't have to mug up all this equation, but try to understand, and once you will start solving many questions, you will be able to remember everything. So this is the equation for completely mixed flow reactor. C is equal to C naught 1 by K theta. So what is the value of C naught? Because we are solving about X, so no need to consider Y. So when we are considering C naught is 500 because it is initial concentration. We have the value of K given, so 4, and theta is 0.5 by 2, so 0.25. This is how we got 250 milligrams per liter. Okay. Now please look at the question, all these questions properly again, and then we can solve for Y as well. So this is the question. Now please try to solve for Y. Okay. What is the concentration of Y? Y can be solved by this part. Please have a look properly and try to solve for Y. This will be question number 3. Then we can see the solution in a minute. This part was not mentioned in the question. Apologies for that. Please note down this thing in question itself. It will be helpful in solving the next question also. This theta is equal to 0.25 days, means HRT, that is hydraulic retention time, is equal to 2.5 days. Theta is equal to 2.5 day. Try to solve for Y. And how much X we got? X is equal to 250 milligrams per liter. So by using these two things and other information, please try to calculate Y in effluent. Earlier Y was 10 milligrams per liter. initial Y is 10 milligrams per liter. Try to solve how much Y we will get in the effluent. We'll see solution question number 3. So the question number 3 was, what is the concentration of compound Y in CSTR after 3 hours? Here T is given as 3 hours. And please solve for 0.25 days also. And these are the options. One is T is equal to 3 hours and T is equal to 0.25 days. So these two things you have to solve. Okay, we'll see the solution now. So the answer is 510 milligrams per liter. How we are getting this? See, now you will be thinking that initially we had Y as 10 milligrams per liter. Okay, however, X is also being converted to Y. Okay, so, and there is no backward reaction. So, some of X is converting to Y and there is also some Y. So there is nothing like, then total Y will be total Y is equal to, sorry, total Y is equal to converted plus original. How much Y we had originally? 10. How much being is converted? Like initially 500, it was 500, right? And how much was left after 0.25 days? 250. So how much is left in 3 hours? Like that we have to calculate. If we are talking about just uh, the one which was given in question number 2, like 2.5 days, then the amount of Y will be more. But when we are talking about the reaction of 3 hours, then it will be less. For 3 hours, it's coming 510. We'll see how. So T is equal to 3 hours. Because everything is given in terms of days, that's why it is important to convert it into day. Be very careful while solving such question because there are chances that K may be given in something per day, maybe something per hour. So be very careful while solving such questions. So now how much Cx? For 0.25 days, how much Cx was there? 250, right? But for theta is equal to 0.125 days, this is how much Cx we are getting. So we need to calculate Cb after 3 hours. Now Cx naught minus Cx upon rate of transformation of x, stoichiometric coefficient of x, and Cy minus C naught stoichiometric coefficient of y. So while these things are there, after that we know this, I have written in the question itself, that x is equal to 0.5y. So 500 minus 333 point C naught, or Cy we want to calculate how much initial was there, 10. And stoichiometric coefficient of x is 1 and y is 1.5. Right? I hope you remember the equation. It was x is equal yields to 1.5y and x is equal to 0.5y. So these two things we have to use for solving this question. Then in place of x, what we have written, 0.5y, and here y. Then after solving, this is what we are getting. Here y will cancel, right? After solving, we are getting Cy is equal to 510 milligrams per liter. Okay, and please try to solve this question when T is equal to 0.25 per day. Okay, please answer me this question in the next session. Please note down it as homework. Now we are talking about question number 4. Now, till now we have seen irreversible reaction. Now we are talking about reversible reaction as well. So what is reversible reaction? Where rate of forward reaction is not so much more than rate of backward reaction. Means there is A is consumed, right? But A is also being formed due to the reaction of B. So the rate constant of the forward reaction is 0.5 per day. Please note down. The rate constant for forward reaction is 0.5 per day. And what is the rate constant of backward reaction? Is 0.8 per day. Initial compounds of A and B are given. So A naught is 250 milligrams per liter and B naught is 150 milligrams per liter. Now molar mass we have to assume 50 gram per mole and 30 gram per mole. Here be careful with the units. These things are given in milligram and the molar mass is given in gram. Okay, so better to convert either all of them to milligram or all of them to gram. So what will be the concentration in milligrams per liter of compound A at equilibrium? First of all, we need to know when the system is reaching equilibrium, and then we can solve this question. Please try to solve this question. I hope you have gone through the lecture. Sir has explained this question, such kind of question very properly. Then we can see the solution. I'll give you 2 minutes to solve this question. Please use calculator and be very careful with the units. Okay, we'll see the solution now. So this is very simple question that see we reached to this equation by solving a set of equations as described in first three lectures. So you can watch all those lectures again to come up with this equation. Do not try to mug up, but eventually if you will solve many problems, you will be able to remember this. So Ca is equal to Kb means rate of backward reaction in bracket initial concentration of A plus B divided by Kf, Kb plus Kf. So very simple equation. Just you have to put all those things and see what I told you. Here we have converted 250 milligrams per liter to grams to take care of the units. Okay. And we got everything in moles. And we then converted it to milligrams per liter again. What was the molar concentration moles of Ca? It's 50, right? So just multiply it and we got to this equation. Multiply this by 50, we will get this in milligrams per liter. Not only 50 but by 1000 also, because molar concentration are given in terms of gram per moles. So multiplying by 50 then by 1000 to convert molar mass into milligrams per liter. So coming towards next question, for this question you need to open your Excel folders. I hope sir has explained such kind of questions very properly. Please note down all the values and open your Excel files. To calculate the fractional order n, we need to round off to nearest integer, and this is our reaction. R is equal to Kcn. I'll write this properly. So R is equal to Kc raised to the power n. It's not in multiplication, it's in n. We have to use regression analysis. Please solve this question. I'll share a screenshot of the Excel file so that you can understand how we are approaching such question. But for a while, take 5 minutes and note down all these values and you can go on with it. I'll share the screenshot to help you to formulate the problem. So this is the screenshot. We are assuming initial k as 0.5 and n is equal to 2. So see, we have to be very careful by assuming these initial values because the solver function will work around these values. It will give abrupt result if the initial values are not proper. So we have time, we have concentration. It's given in question, right? We calculated dc by dt. Okay. Then this is dc by dt. dc how we are calculating? 400 minus 450 divided by 1 by 0. Okay. This is how we are calculating, and this portion is done by back calculation. Then so we are getting the rate. How we are getting the rate? Just by multiplying dc by dt by minus 1 because rate we are assuming positive, so that's why. Then model rate, error and error square. What is model rate? Model rate is nothing but like k cn, like we have to just put whatever you are getting, like by using these k and n values we will get this model rate. What is error? Just subtraction of these two rates. So we are calculating error square. You can do these two things in one step as well. We're calculating error square and this is the sum of error square. We want to minimize this. So while using solver function you can just go to the options. Then there will be add-ins. Then you can go to solver and just close and open your Excel system again. You will get the following thing. So this is where a solver function is very important. When you will use this, these values can be changed, and you are getting, for this question you are getting k as 0.49 and n is equal to 0.73. Now the question is saying to convert it into nearest integer, right? So n is 0.73. What is the nearest integer value? It's 1. So that's why we converted 0.73 to 1. So this is how we are doing it. Please follow exactly all the steps that as explained in the lecture. You can get these values very easily. Coming to question number 6. Due to accident right before nationwide lockdown due to COVID-19 pandemic, an unknown amount of BZC, benzyl chloride, is introduced in small, well-mixed pond. Means it's a kind of continuous mixed flow reactor. It is mixed well, so we can assume this as continuous mixed flow reactor. Now it is a drinking water reservoir. Working for the state water authority, like you have been asked to estimate how long it will take until the concentration has dropped below 1 microgram per liter. We want to calculate the time. Because of the lockdown, it takes you 5 days until you are ready to make the first measurement. Like by some accident, this happened. So we have some C0 concentration, we don't know. But you were able to take measurement only after 5 days. ये measuring time, this is measuring time, is 5 days. Means if this was C0 as 0, this is 5 days, this is the day you want to calculate. Something like this is happening. C0 we have no idea about. You were able to calculate on the 5th day. means this is the calculated value. You were able to, you had some machines, you had some probe or maybe some sensors by which you were able to measure the concentration on the fifth day, and this concentration is how much? 1 microgram per liter. 1 microgram per liter. So we want to know this time. Our goal is to know at what time the concentration will drop to 1 microgram per liter. So what do you have exactly? You have only Cc values and time. You have only this concentration. And how much it is? This concentration is 50 micrograms per liter. Okay, this is 50 micrograms per liter. So I repeat again, this is a pond in which you want to measure the concentrations. The concentration may go like this: 0th day, this is 5th day, and this is the day you want to know. Means this day is given in the options. You have no idea how much initial concentration was there, but on the 5th day you measured that it is 50 micrograms per liter, and you want to tell the government at how many days this will be 1 microgram per liter. So you have these data. Okay. So at this time, that is 5 days after the spill, the measured VCZ concentration in the pond water is 50 microgram per liter. A second measurement 5 days later, that the concentration is 23.6 microgram per liter. So second measurement after 5th day, again on the, maybe it may reduce it further. So we want to measure this maybe after 10 days. Again we measured the concentration, it was 23.6 microgram per liter. So we want to know at teeth day, at how many, after how many days the concentration will be 1 microgram per liter. Okay, so you have two concentration, two times. Initial concentration you have no idea, and you know the final concentration, but you don't know the final time. So by using these values, first try to form the equation, then by using that equation we can get to the final time. Please try to solve this question. We'll see the solution, then maybe in case of doubt you can understand what is going on actually. Please try to solve this question if you are understanding the question. we'll see the solution. So, C5 concentration on the fifth day of spill, and C10, so I'll draw this again. So, this is, let's say, fifth day, and this is, let's say, 10th day, and this is what we want, 10th day. Zeroth day. What was zeroth day? C0, C5, C10, and this we want to know, CT. C0 we have no idea about. C5 was 50, C10 was 23.6. So a well mixed pond is example of batch reactor. Since they are not talking about any incoming flow and outgoing flow, we can consider the completely mixed stirred tank reactor as batch reactor because there is no incoming and outgoing flow. So 50 is equal to C naught. What is the equation? C is equal to C naught e raised to power minus kT, right? So on fifth day, what is the concentration? It's 50, right? So we are getting this equation. On 10th day, what is the concentration? This. Upon solving, we have two unknowns, right? K and C naught, and two equations. It can be easily solved. So just you have to solve these two equations by any means you can use. You can even make it into ln, like you can do like this also. Ln 50 is equal to ln C naught minus 5k. This also you can do. ln 23.6, whatever your favorite way is, you can solve this equation. Ln C naught minus 10k. In this way, you can eliminate k also, C naught, or just subtract this equation, you can get rid of C naught also. Or you can multiply this equation by 2 and get rid of k. So whatever the way you want. So here we have just divided this equation by this equation. So this is what we are getting, k is equal to 0.150. So now putting the same in equation 1, we are getting C naught. We are putting it in equation 1, C naught a raised to power minus 5 into 0.1501555. This way we are getting C naught. What is C naught? 100.593. So how much what we got? 105.93. Now the final question is C is equal to C naught e raised to power minus kt, right? Now we have the value of k, we know the t, we want to know the t, we have C naught also. So just simply put all these things in the equation. 105.93 e raised to power minus what is k? 0.15 multiplied by t. Just by solving this equation, you can get t as 31.05 days, which is 31 days. So this question was simple, the language was complicated, but try to break down the question into smaller parts, then you can easily solve this. Just while solving such question, you can make graphs like this. And most of these questions will be based on this equation only. If not this equation, then this equation will be there. Either of these equations, the question will work. And how do you know if we need to talk about this equation or this equation? Just read the question properly. In this question, it was very clearly written that it is well mixed pond. So either of these things can work because it is well mixed pond. But further, there is no information on incoming or outgoing flow. Therefore, it is batch reactor. Then we will use this equation. Moving forward to next question. Answer is also given. Select the correct option about Bronsted-Lowry acid-base theory. Now we are jumping into acid-base type question. See, now we will solve only some theoretical question, but in the next session, it will be mostly acid-based numerical question. So please, next session, read the lectures, try to understand it very properly to solve it. So we are talking about Bronsted-Lowry acid-base theory. This is kind of a memory-based question, that it is widely used theory as it applies to both aqueous and non-aqueous solution. It is applicable to aqueous solution or the definitions. So as you can see, answer is there. First of all, it is only applicable to aqueous solution. Only in aqueous solution acid will behave the way it is behaving for this theory to come true. Acid will behave very differently in non-aqueous solution. So most of the theories or most of the acid bases problem that we solve are based on aqueous solution, means polar solvent, that is mostly water, because water is also dissociating into H plus and OH minus. So any acid that will react with water will give rise to more of these compounds, any acid or any base, depending upon this, if it is acid or base. So these things are there. So most of these theories are applicable to aqueous solution only. So first point is always with this, and second is acids are those compounds which are capable of denoting proton, H plus, obviously, like HCl, hydrochloric acid is acid. What it is doing? It is donating H plus and Cl minus. So because it is able to donate H plus, this is called acid. If it can accept H plus, it will be base or conjugate acid. Okay, this is Bronsted-Lowry theory. Please remember this. Moving towards next question. A particular industry needs fluoride ion in the water solution for chemical production. The source of fluoride is HF, hydrofluoric acid. What will be the ideal pH value at which the industry must operate? pKa is 3.17. We are using HF. How it is dissociating? H plus, F negative. So there is one more information about HF. In laboratory, all acids are delivered in glass bottle. Okay, but this HF is delivered in plastic bottle because HF is the most dangerous acid. If we are putting HF on any surface, it will start making hole on that surface. It can be ceramic, it can be iron, it can be steel, glass, anything. If we are putting HF, it will start making hole. But only plastic can hold HF. For other acids, they are always delivered in glass bottles, but HF only and only plastic can hold it. So this is some extra information, might be interesting to you. So HF is giving H plus and F negative ion. So what is pKa? First let's talk about Ka. So Ka is H plus F HF. So this is Ka, which is equal to 10 raised to power minus 3.17. Because pK is 3.17, so K is equal to 10 raised to power minus 3.17. So we need to find out F, means our basic aim is, like, what is our target? Our target is forward reaction. Okay, our target is to go to forward reaction. Backward reaction we don't want. So therefore, anything which is greater, our target is forward reaction, means we want numerator to increase and denominator to decrease, right? So, because we want more fluoride ion, less HF, numerator should increase, denominator should decrease. So, when the numerator is increasing, then there should be, if the pKa is there, then the pH should be greater than pKa. Like anything which is giving more fluoride ion is acceptable for us, right? In such questions. So only this pH is having more value than the pKa. Then only the reaction will move in forward direction. So that is why this is the correct option. Moving forward, acetic acid. Acetic acid is written in this form, H plus acetate ion. This is acetate ion, means CH3 C double O. So this is acetate ion. So HAC dissociating into H plus and AC negative. pKa is given. The concentration of conjugate base and conjugate acid at present after dissociation is, this is 10 raised to power minus 4.6 mole per liter and 10 raised to power minus 2.8 mole per liter. We have the concentration of HAC and AC. Calculate the pH of the water solution. Use Henderson-Haselberg equation. So this is Henderson-Haselberg equation. This is one of the most basic equation. We use this equation for calculating buffers. So this is the most common use. Here we are solving this question. So pH is equal to pKa plus log acetate ion divided by HAC. So mostly it will be in this form only. So pH is equal to pKa, just substitute the values, all these things, you are getting pH is equal to 2.96. I hope there won't be any doubt in this question. Remember this equation, this is very important. Now talking about the last question, which of the following acid is strongest at pH 8? We are talking about pH 8 and we are talking about the strongest acid. We have to assume that all the concentrations are equal. This is also given, but even if this part is not given, just assume that and solve the question. For HOCl, pKa is given, HOBr, pKa is given, HCl, and the other, this is alcohol, for this also pH is given. So we need to calculate which acid is strongest at pH 8. So answer is given that HCl will have more H plus than any other compound because pH is greater than pKa. Like what is pK? As I have explained in previous question, means H plus. Here let's take first part, H plus, OCl negative and HOCl. So to make a acid stronger, we want it to dissociate more. If it is dissociating more, what will happen? The numerator will increase and the denominator will decrease. So, and both of these will be at equilibrium at certain pH, right? That pH is pKa. So if anything is greater than 7.53, it will increase the capacity of the acid, which will make it stronger. So that is why at pH 8, because pH is greater than pKa value, HOCl is stronger at that particular pH. And we will go through acid based questions properly, mostly numerical based questions in the next session. Please watch all the lectures properly, note down everything, and in case of doubt you can ask in the forum also. Like in case of you are getting doubt at a particular point, there is an ask question box. Click on that and ask the question. You can ask there itself. We'll try to solve all those questions as well and go through all the assignment questions. and submit it on time. Okay. So any doubt for now? I know these environmental chemistry course is little tough, but please bear with us and just try to learn more. Watch the lectures, go through it 2 3 times, and environmental chemistry book you can read Sawyer and McCarthy for the basic concepts. And sir has also suggested few more books. Please read those things properly. You'll be able to get it. Okay, since there are no questions anymore, we'll close the session. Bye bye. Have a nice day.